welcome you to Mathematics Set Theory 1. Here we're going to look at sets, and below are some of the symbols used in sets, but we know very well that a set is a collection of objects, ideas, and so on. So, symbols used in sets are these ones. These curly brackets are used to mean that that's a set or set of. This one is used to indicate that it's a member of that set. For example, you can say A is a member of set B, like that. If we are given set B and A is a member, we represent it like that. This one is just the opposite of this one. It says that this one is not a member of n number of members. This small n. Now this one is for intersection, union, universal set. Intersection is what is in the other set and in another set. The equal thing, the similar things in both sets. Now here we have union sets. The union set comprises of everything we are talking about. If it's set A and B, it means the union is the combination of members from set A and set B. Universal set comprises of everything in the sets given. Now this is complement. If they set A complement, they mean all elements which are not included in A. So you write all the elements which are there except those ones in A. Now we're going to have an example, a brief example, which will show us how we can use some of these ones which are common. Now they are giving us an example that set A is comprised of 1, 2, 3, 4, 5, 6, and 7. These are counting numbers. And set B is comprised of 1, 3, 5, 7, 9, and 11. These ones are odd numbers. Now they say find part A intersection B. We read this one, set A intersection set B. Now if we want to carry out our solution, we say that set A intersection set B. We look for those ones which are in set A and in set B. So we say part A, set A intersection B is going to be, we open the set as we said. Here we open the set and indicate everything which is here and here. You can see 1, 3, 5, 7. They are all here. So 1, 3, 5, and 7. These ones are the members which are both in set A and B. For union, A union B is going to be, we are going to select every element in set A and set B, but not repeating any. So we are going to look for these ones and write each element once, all of them. So we are going to write from 1 up to 11, but not repeating any of the elements. So we have 1, 2, 3, 4, 5, 6, 7. I think there is no 8. Go to 9, because 9 is here, and 11. Now parts they are telling us, find the number of elements in A intersection B. Now here they want the number of elements. In part C, they want us to count the number of elements in set A intersection B. Now we come here to that set and look for number of elements there. There are 1, 2, 3, 4. So we write 4 elements. We go to D. For here, our D, they want number in A complement. Now I told you A complement, we write everything except elements of A. So A complement, we can identify from there that we are going to write everything which is here except those ones in set A. So here we want the number of elements in A complement. Now we are going to leave all those ones in A and we leave all those ones which are in B, but they also appear in A. So we're going to select only 9 and 11 to be our members which are in A complement. But here they want the number of elements there. So there are only 2 elements. Now what we're going to look at is part E, which says number of A intersection B but complement. It means we go for all elements in A and B, which appear both in A and B, but we exclude them. So we are going to look for E as number of elements in A and B complement. In A intersection B complement. So we are going to come here. We look for all elements which are in A and B, then we exclude them. The rest we count them. So it's this one A. One we can see it here and here. 3, 5, and 7. So we exclude them. Then we count the rest. We have here. We can see that we have 6. That's 1, 9, and 11. Those are only the 3 elements. So this is how they can ask questions not in words. They can ask in word form or in this demonstrating sets themselves. So here they have showed us sets themselves, but sometimes they can ask us using words, just real words, and we convert them into sets. We construct sets by ourselves. So let us look at an example where they can tell us to calculate, but when they have not given us real sets from words. So we remove from words, we make our own sets. So let us try out this one. Here we're going to look at this second example, whereby they give us words or statements and we are able to form sets from them. Now here we're going to try to solve this question. As they said, in a certain group of children, all of them study French, German, or both languages. Now you have seen that they study French, German, or both. So there are only 2 subjects in the study. So let us use in our solution. We first select, we are going to use, so you say use F for French and G for German. As I said, they study French, German, or both languages. 15 study French but not German. So it means if they study French but not German, it means 15. They're going to say 15 study French but not German. So we say number of those ones that study French only. If they say but not German, it means French only. They are going to be 15. But not German. 12 study German, of whom 5 study both languages. Now, out of these ones, out of these 12, we have those ones who study German only, and other 5 who study both languages. So we're going to say number of German. Here we don't put only, there are 12. But we know very well that they say 5 number of those ones who study both languages. This is French, intersection, German. Because both, it means intersection. There are only 5. It means you are going to get number of those ones who study only one language, that's German, German only. We just get 12 minus 5. So number of those ones that study German only is equal to 12 minus 5, which is 7. Now this is not the question, but we are just trying to collect data. The question is here. Draw a Venn diagram to show this information and use it to calculate how many children and they are in the group. Now we are going to represent this information on a Venn diagram. Here, and they want the universal set here. They want us to determine the universal set. That's what we are looking for. Now in the Venn diagram, we know very well we're going to construct it. We have two sets. This is the first one. Another one is here. Now we are going to label these two sets. The first one is French, F. Number of F, we are going to put them there. Number of German, we are going to put them there. This is intersection. We have the intersection, we know them, they are 5. So these ones, they are 5 students, or 5 children who study French and German. Now here, these parts are the only we have. So we have French only, we put it here, and German only, we put it here. We have French only, it is 15, German only, it is 7. Now to get the value that we put here is this plus this, because it's the whole set of German. So this is 15 plus 5, which is 20, and this one is the whole German, which is 5 plus 7, which is 12. They said all of them study French, German, or both. So we don't have anyone who is outside these two sets. So outside here, the complement set, we don't have any. So we can put there 0 or we can leave it the way it is. Now, the universal, they told us they want us to look for it. So we can decide to name it X. So let number of universal be equal to X. Now we are going to solve for this X. But this X is equal to all the members in this set, or all the children in the group. So it means if we want to get the X, we add everything which is here. Now to add, you're going to say universal, number of universal, all this is equal to X is equal. You're going to add everything which is here. You're going to add 15 plus 5 plus 7 plus 0, because 0 are those ones who do not study French, not study French, and they don't also study German. But in this group, we have only those ones studying French and German. So we are going to add these ones, and these ones. So this is 15 plus 5 plus 7. So here the universal set is going to be 15 plus 5, you get 20 plus this one is 27. So 27 children are there in the group. So the number or the universal is going to be 27 children in the whole group. Now let us look at another example which consists of 2 sets, and from there we're going to go to those ones of 3 sets. Now let us look at the second example. We are having a question in detail. So we have to break it into sets such that we simplify it. This question is big, it's set in section B, so be ready to be asking such questions. So you're going to be able to interpret every information given in these statements such that you can obtain what they want. They're telling us that 56 soccer fans supported 3 African countries' soccer teams playing: Algeria, Cameroon, and Liberia. And these countries are being given letters. Algeria is A, Cameroon is C, and Liberia is L. 32 watched Team A play. So it means we are in our selecting of data, we are going to be noting every information we are going to be reading. So here we are having A. So we are going to use number. We are having A, number of B, number of Liberia, which is L. 32 watched Team A play. It means For A we put 32. 18 watched C playing. This is 18. And 30 watched L playing. So this is 30. 20 fans watched both A and L. So both means intersection. So you're going to say number of 20 watched both A and L. It means A intersection L. It is equal to what? To 20. So this is 20. Number of 12 watched both A and C. So A intersection C is equal to 12. And also 8 fans watched C and L. So 8 watched C and L. This is how we represent this information up to this point. Now here they're telling us that the number of fans that watched all the 3 teams playing. Now here the number of fans that watched the 3, we say A intersection C intersection L. They are telling us it is equal to the number of those that they did not watch any of the 3 teams playing. So this one means number of A union C union L complement. So we are going to let this one to be equal to X because they have not given it to us up to this point. They told us using a Venn diagram, find the number of fans who watched all the 3 teams playing, determine how many fans watched at least 2 of the teams playing. So we are going to represent all this information which we have summarized on a Venn diagram. So this is a Venn diagram which we are drawing. So here if we're going to represent the universal set, they told us that number of fans, they were what? 56. So it's equal to 56. So we start with that one. Can put it here, can put it here. Anyway, so we said that number of universal is equal to 56. Now we're going to bring this formation. Let us name this one A. Let us name this one C. Let us name this one L. For A, they are 32. For C, they are 18. And for L, they are equal to 30. We are representing every formation given there on a Venn diagram. Hope we are following. Now from there, we are going to come to this intersection. Means that A intersection L is this section which combines A and L is this one. So the whole of this one is given by 20. So what we are going to do, for us we are going to first focus on this last statement which tells us that all those ones who watched every game are X, and also those ones who watched nothing, they are X. So out here are represented by this one, we put there X because we have left it. And even this one, we put there X. That's what they told us to do. Now, this is for all those ones who watched everything. Those who watched all the 3 teams playing. Now here, we are going to put intersection of A and L minus that one we have of the 3 teams. So we are going to get the intersection and we subtract X from that. So we have A intersection L, we're supposed to put it here. But remember this 20 is for all this portion. So what we are going to do is to get this 20 minus X. To do the same for A intersection C, it is 12 minus X. C intersection L, it is 8 minus X. As that, we are representing this information on a Venn diagram. Now, these ones, they have not given them to us. This one, it means these ones are the fans who supported only Liberia playing. They never went to support Cameroon, they never went to support Algeria. They just watched the match of Liberia. Even these ones were for Cameroon, even these ones were for Algeria. So we are going to use our letters to represent these ones. So let us name this one small a, this one small b, and this one small c. Or if we consider these ones, they appear somewhere, let us change to give them any other name, but let us put these small ones to represent everything we want. So we are going to call this one small a, small b, and small c. So this is the representation of information on a Venn diagram. Now we are going to look for what they are asking for. Find the number of fans who watched all the three teams playing. They want the intersection part. This intersection part is got by calculation. We have to calculate such that we obtain the value of x. The value of x is going to give us the fans who supported all the three, or watched all the three teams playing. Now, how are we going to obtain this one? We are going to use the idea that the whole of this one, the Venn diagram, is equated to 56. The whole of this section is equated to 30. The whole of this is equated to 18. The whole of this is equated to 32. Now what we are going to do is to add everything which is here and equate it to 56, because that's what we know. Now in solution for part A, we are going to say that every information which is here is going to be equated to 56. But we are going to look at this A. The whole of this A is 32, we know that. So we're going to take this one and 32. So we know 32 plus, we have already added everything which is inside here. So we're going to add this one plus this one plus this one plus this one to equate to this. So we add plus b plus this one which is 8 minus x plus c. Then we add plus x. This one will give us 56. 56. And from mathematics we know that this one and these ones are on the same side, so we can add this one plus this one. We get what? 32 plus 8 will get 40 plus, but this one and this one, this is negative, this is positive, so they are going to cancel out. So we're going to remain with plus b plus c equals to 56. Then here, what are we going to obtain? Here, we're going to make sure we take this 40 this side. So we're going to remain with b plus c equals 56 minus 40, which is 16. We're going to name this one equation 1. After naming it equation 1, we are going to obtain another equation which will help us to solve. Because we have one equation and we have two unknowns, b and c. So we can't solve them at once. Now let us look for another rule we have. We know that the whole of this one, Liberia, is 30. So let us add everything which is here and equate to 30. So everything which is there, we have 20 minus x plus x plus 8 minus x plus small c equals to 30. Now here we have 20 plus 8, that's 28. This is negative, this is positive, we know these ones will cancel. Now this is minus x and then c. So this is minus x plus c equals to 30. Now it's the way of getting this one, we put it the other side. So if we get 30 minus 28, we are going to remain with only 2. And if we get negative x plus c, it's the same as c minus x. Now this one is going to be our equation number 2. We are going to go to equation number 3. Class, hope you are following. We are going to go to equation number 3, where we are going to obtain it from here, from this section. we know that the whole of this one is 18. So we are going to add every information which is here and equate it to 18, which is 12 minus x plus b plus x plus 8 minus x equals to 18. Now we know this is a negative, this is a plus, so these ones are going to cancel out. Have 12 plus 8, that's 20. 20 plus b minus x is going to be equal to 18. Now we get this one. We put it the other side. So it's going to be 18 minus 20. 18 minus 20 is going to give us negative 2. That negative 2 is going to be b minus x. So this is equation number 3. This is equation number 3. Now we have 3 equations, 1, 2, and 3. And you can use those 3 equations to obtain the value that we want, the value for x that we want. Now here what we are going to do is to use this equation and we substitute in it. We substitute, so we'll say substituting in equation 1. What are we going to substitute there? We're going to substitute for c and b. We know very well that equation 1 is b plus c equals to 16. Now we're going to bring b. Like how we're going to get this one, we make b the subject by taking this one this side. We're going to obtain b by getting this one, we put it the other side. It's going to become b equals x minus 2. So here we're going to have x minus 2 in position of b. From here, plus, how are we going to obtain c? From equation number 2. By bringing x, we put it this side. So it's going to be, so if we bring x this side, it's going to become a negative. It's going to become a positive. So you're going to have c equals 2 plus x. This one is going to be equal to 16. Now from there, we're having these 2, which we have substituted in positions of b and c. So this one is x minus 2 plus 2 plus x equals to 16. From there, we can easily obtain that, we can easily see that this is negative 2 and this is positive 2. So these ones are going to cross out, and we had x plus x, you're going to be having 2x, which is going to be equal to 16. Now from here, we are going to divide 2 throughout. Divide by 2, divide by 2. And we are going to obtain x as 8. It means the value of x here is going to be 8. And it is the solution to our question in part A. Now it means the fans who watched all the 3 teams playing were 8 fans. But we haven't substituted, because after substituting in this Venn diagram, it will give us all the information we need to use in part B. Now after using this one, we say, therefore, 8 fans watched all the 3 teams playing. So this is the solution for part A. Then now let us look at part B. Now from here, we have obtained the value of x. It means it is relevant for us to substitute the values of x and the unknowns we have in the question. So here, we know this is 8. Even this one is equal to 8. Now this is 8 minus 8, which is equal to 0. This is 12 minus 8, which is equal to 4. This is 20 minus 8, which is equal to 12. We are just simplifying. So B, remember from our B, we said B minus X is equal to 2. So we can obtain B. We said B minus X is equal to negative 2. So we can get B minus 8 is equal to negative 2. We bring negative, we put it this side. So our B is going to be 8 minus 2, which is 6. Also C, we have it here. C minus x is equal to C minus 8 is equal to 2. Now we bring this one. This side is going to become a positive, so C is going to be equal to 10. Here we can substitute. This one is equal to 10. B is equal to 6. Now we don't have A, but we need it also. We need A also to be there. If we want to get the value of
welcome back for the second session, and now we're going to be talking about what we call formulae. A formula comes from the word formula that you are familiar to, and we know that a formula is a mathematical sentence, or a mathematical statement in which one quantity is expressed, in terms of other letters. It can be letters, numbers, and numbers. Let me stop there. A repetition. For example, area of a triangle equals length times width. So that's how we write it. So that the formula, I will say A equals length times width. So you come and say A equals length times width. This is a what? A formula. So that's the expression I mean. So that's what we are going to talk about today. We have what we call change of subject of the formula. Under formulas, we want to see how can we change the subject of the formula, and how can we use the formula to substitute numbers using given numbers and get the value of an unknown. So that's what we want to do. So in changing the subject of the formula, we have examples. Number 1, make T the subject of the formula. I come here and start. 1. If I have this, it means that I can first interchange and bring this one this side. I say, under my solution, I say U plus AT equals V. That's step number 1, which is correct to make the work easier. Then I say U minus U plus AT equals V minus U. I'm taking U the other side. I want to remain with the T. So this U cancels with this. I remain with AT equals V minus U. What next? I will divide by A, both sides. I divide by A. So it means T equals V minus U out of A. Haven't I made T the subject of the formula? I have made it. As simple as that. It is so enjoyable, and remember it is commonly asked. So understand it. Part 2. Make A the subject of the formula from C equaling to root NA. Let's see how to do it. We have C equaling to root NA. The first step, I want to remove divide by 2 both sides. Dividing by 2 both sides, what do I get? I'll get C out of 2 equaling to root NA. Then squaring both sides. Squaring both sides. Squaring both sides. What do I get? Squaring both sides. So I will get C out of 2. This is squared, which is equal to NA. Let me show you. I wanted to jump it, but let me show it to you and I will explain to you this one. When I square, this is a root. Squaring, so this square will cancel with a root. So I will remain with C squared out of 4. This will square itself independently and this one independently. So what am I having? What I'm having is well known as C squared out of 2 squared, which is equal to NA. Because when I have the root of any number, then I square, this square cancels with that, and I remain with what? With 9. So that's what I'm doing here. This has cancelled with that, and then I will remain with C squared out of 4, which is equal to NA, and then we are making A the subject of the formula. I divide by N. So this will cancel with that. So here we get C squared out of 4N is equal to A. Therefore my A is equal to C squared out of 4N. You can see here, if I have C squared out of 4 divided by N out of 1. So this shall be C squared out of 4 because it is mere N, so down here it will be 1. So times 1 out of N. You change the sign and do that reciprocal. I hope you know that. So it will be C squared out of 4N, and this is what I have here, and I have finished. Yeah, that one is done. Let's go to example 3. Example 3 is saying if x equals AB plus C out of D, find the value of x when A equals 2, B equals 3, C equals 4, and then finally D equals 10. So in my solution, I will first come and say x equals AB plus C out of D, and then they are saying x is equal to A is 2 times B is 3 plus C is 4 divided by D is 10. Anything left? No. So my x shall be equal to x plus 4 out of 10. My x shall be equal to 10 out of 10, which means that x equals 1, because 10 out of 10 is 1. Then they are done. Lastly, this one I may give it to you as assignment, or I can give you a hint. They are saying that if I equals nRT out of 100, find the value of I when P equals 200, I equals 5, and P equals 4. It is the same thing we have done that side. Because this one is constant, because it's given, you can't change it. And they are saying T when I is 15, other 10, and N 3. It would be better if you are to work on T, better first make it subject of the formula if you can, using the previous work. After making it subject of the formula, you can go ahead and work it out. So this is what I'm giving this one to you as exercise. I'm to inform you that we are soon finishing our O-level work, and I'm leaving the rest of the content for my colleagues. I'm only left with only one tutorial. Thank you for following me.
Once again, I welcome you to Digital School Uganda. Today we are going to have ordinary level mathematics, indices. Now when we talk about indices, we deal with indices, all powers and bases. We have the number and it is powered by something. That one, we call it a power or an index. Like for example, I have x squared. This one is a base and this one is a power. This x, or if we have 5 power 3, we know very well this one, 5 is a base and 3 is a power. Now from there, we know very well, we can recall that a times a, we get a squared. A times a, we get a squared. A times a times a times a times a. Because these ones, it is a 5 times. It is not 5a. It is not 5 times a. It is 5. It is a power 5. Even here, it is a times a times a times a. This is a power 4. Divided by a times a. This is a squared. This gives us a times a. Why? Because 1a is going to cross out with this one. 1a is going to cross out with this one. We remain with a times a. And we say that a times a is a squared. So this is our answer. From there we go to laws of indices. And these laws of indices, they will not ask you to state them at any point. They will just bring a question and you will need to apply them in solving that problem. So, we have a list of laws. There are many. As we go on discussing this topic, you are going to see them. We have a law that says that if we have a base A powered by a power times another the same base powered by a different power. Here we just add the powers. We maintain the base and we add the powers. I hope this one you know. And we're going to see this in our examples that we're going to try out. Here we have, if we have the same bases but different powers, even if the powers are the same, but if we are dividing and they are the same bases, we maintain the base as it is here, and we subtract the powers. Starting with the first, we subtract the powers because this one is division sign. Now, if we have a base powered by something, again, we are powering it by something. We just maintain our base and multiply these powers. For example, we may be having 2 power 3, again, power 5. Here, we maintain our base, which is 2. Then we power this multiplied by this, which is 15. This is the simplification for this. So, if we have a base and it is powered by 2 things, then it means we are going to multiply the powers. If we have a negative power, it means we are going to get the reciprocal of the base. It is 1 over, this one is negative. If we want, we make it a positive by getting 1 over that one. If we are dividing these powers, if we have a base and we are dividing the powers, it means you are going to get a root of one of the powers which is down. It means if we have, for example, if we have 2 power 3 over 4, it means we are going to have 2 power 3 because it's the one up. Power 3. Again, we get the 4th root of this solution. Get the 4th root like that because 4 is here below. So this is the expression for this. This is the 5th law. We got the 6th law. It says that if we have a fraction acting as our base and it is powered by negative, this one gives us a positive power when we have gotten the reciprocal of the fraction which we have in the bracket. We shall go on, there are many laws, we shall go on separating them one by one. But from there, we shall look at some of the examples. In our examples, they are telling us, number 1, write the following numbers with single index. How it means that index, for this case index, we know very well is the singular form of indices. Now they want us to write this one with a single power. Now what are we going to do? From the first law of indices, we knew that if we have a base powered by something times a base, the same base powered by something. Here what do? We say that we maintain our base, which is 2. And since this is a multiplication sign, we add the powers. Here we're going to add 5 plus 3. And our solution is going to be 2 to power 8. And this is the solution to part A. Let us go to part B. Here if we have part B, they are telling us that we have the same base but different powers. So if we are dividing, it means we are going to subtract the powers because the base is the same. So here we are going to maintain our base, which is 12, Then what are we going to do with the powers? Because it is division sign, it means we are going to subtract the powers, which is 15 minus 12. So this one is going to give us 12 power, this one is 3. So this is the solution. They told us they want a number with a single power or single index. Now here we have the same. We have this powered by 2, again powered by another 3. But we say that if we have a number powered by an index here and again another index, means we maintain that base and we multiply the powers. So this is going to be 2 times 13, which is 26. Divided by, here we are going to do the same. X, maintain our base, then we multiply these powers, which is 2 times 8, which is 16. Now here, what is going to give us, we are going to make, we are dividing. Remember, we are going to apply another law, which says that if we are dividing the same base, we maintain our base, and then subtract the powers, which is 12, which is 26 minus 16. This one is going to give us x power 10 as our solution. Now we go to part D. Part D is again a combination of some of these laws. We know very well this one is 3x power 5 times 8x power 4. Now we can first work on these two, then we bring in the third one. Now what are we going to do with these two? We know that this is 3x power 5 times 8x power 4. Now we are going to show it here. But we're going to first work on this, which is 3x power 5. These ones are real values, so we are going to just multiply them. We're going to multiply 3 times 8, to bracket, then x. Because this is multiplication, we have multiplied, then we bring in x. Then times x power what? We have 5 here times 4. So it is 5 plus 4 from the laws of indices. Now we have simplified this one. Now we are going to say divide by 12x power 2. Now we know very well that 3 times 8 is 24. So this is going to be 24 x power what? 5 plus 4, it is 9. Divided by 12 power x power 2, like that. Now, we first work on these numbers, these figures. We get 24 divided by 12. So, 24 divided by 12 is going to give us what? It's going to give us 2. So, we are done with these ones. So, we are going to say that x power 9 divided by x power 2. Now, it is going to be, we maintain our base, then we subtract the powers, as you know very well. It's 9 minus 2. So, it's going to be 2x power 7 as our solution. Now, after we have solved these examples, you are able now to try out this exercise. It is only one number, part A and part B. You are going to be able to try out these ones. Treat these ones as real numbers. Where you need to add, just add fractions. Even decimal points, just add or divide like that. It's as simple as that. Let us look at another format of how they can tell us to simplify indices. If they tell us to simplify such numbers, we combine what we know about addition and subtraction and division or multiplication, and again we bring in the ideas of the laws of indices. Now here, you're going to focus, if they are telling us to evaluate this one, how are we going to evaluate? In our solution, I think I'm going to try out part A and B, and part 3 I'm going to make with it for your revision. Now here, they're giving us 27 p power 6 divided by 9 p power 3. I've told you that if they bring numbers within indices and powers, so it means that we are going to treat these ones as indices also. Now here we know 27 and 9 are all multiples of 3. Now we're going to try this. So we know that 27 is equal to 3 times 3 times 3. This is 3 power 3. And also 9 is equal to 3 times 3, which is equal to 3 power 2. Now instead of writing 27 here, we are going to write 3 power 3. Even this one for 9. Now these ones you are going to maintain them, so our question is going to change. It's going to become 3 power 3 p power 6 divided by 3 power 2 p power 3, like that. Now here we have this and this. These ones are like real bases. 3 and 3, they are bases. So what are we going to do? We first maintain the bases. For these numbers, we are going to maintain the base because it's division between them. So we maintain the base as 3 and we subtract the powers. So we're going to subtract 3 minus 2, which is going to give us 1. Again, we go to P. P is also having a single base, which is P. Then we subtract the powers because the symbol which is here is division. So it is 6 minus 3, which is 3. So here, 3 power 1 is the same as 3. This is P power 3. So this is solution for part A. Now for part B, is again different from this one. For part B, if the power is up here, we are going to make sure the power enters here, here, here. So there is going to be a power here, it's going to be a power here, there is a power here, because it is taking the whole thing. That's the meaning of these brackets. So if we enter these 3 inside here, we're going to have 3 power 2, again power 3, times A power 3, again power 3, times B power 3, like that. But I told you that if we have a power inside and a power outside, we multiply the powers. So after multiplying these two powers, we're going to have 3 power 6 times A, these are powers, it's going to be A power 9 because of the 3 times 3, times B power 3. Now it's better for us to start with these ones. If they are multiplication signs, we can even leave them. We can even leave these multiplication signs. This is the answer, but we can simplify it and say this is equal to 3 power 6, A power 9, B power 3 as our solution. Now from here, you are able to apply the same idea to this question. Thanks. Now let us continue with some more examples. If they bring now roots, square root, cube root, fourth root, fifth root, and indices, how do we deal with them? They're telling us to simplify the following. For part A, it has a root. Now here, what do we do if they bring a root? We just know that a root means power a half. So if the root is onto the whole thing, it means we are going to write the whole thing, which is 9y power negative 6. Then under a root, a square root, I told you it is the same as 1 over 2. So it means this is a half powering this. It's the same that represents a square root. Now here, we know very well, we have learned that 9 in indices, we write it as 3 power 2 because it is 3 times 3. So this one, we write it as 3 power 2. Then this one is y power negative 6 into 1 over 2. Now since the power is up here and is taking the whole thing, we say that we multiply the power, we bring it here, and we bring it here. So we're going to bring the power here, we're going to bring it here. How? We're going to multiply this power by this 2, which will give us 3. 2 into half, again, y negative 6 times a half. So the solution is going to be This is 2 times a half is going to give us 1. So 1 is the same as rating 3. Power 1, the same. 1. This is negative 6 times a half. This one, you press your calculator and you get negative 3. This one is the same as 3 over y. You bring this one down because it's having a negative power to have 3 like that. This is our solution to part A as this. Let us look at part B. Part B is telling us that 10 power 6 times 10 power negative 7 over 10 power negative 2. Now, if they give us the same base, but different powers, and up we have some powers which are negative and positive. Now, if the power is negative, just know if it is at the top, you're going to bring it down. The whole thing, you're going to bring it down, and the power is going to become positive. If it is down, you're going to take it up, and the power is going to change to positive. So here, since this one is positive, we are going to maintain it where it is. It is 10 power 6 times. Since this one is 10 power negative 7, we are going to bring it down, and the power is going to change to positive. So it's going to be over 10 power 7 because you have changed it from up to down. That's why the negative went away. Now, this one is 10 power negative 2, but it is below. So we take it up, which is going to be 10, 2 for that case. Now from here we apply the laws of indices, which says that if we have the same base, we maintain the base, and then we multiply. If it's multiplying, we add the powers, which is 6 plus 2, which is going to give us 8. Even here we have 10 power 7, and this is division. We are dividing numbers of the same base by different powers. So what I'm going to do, we maintain the base and we subtract the powers. It's going to be 8 minus 7, which is 1. So this is the same as 10 power 1. Hope now we are going to be able to try out this one. But just know that if they give us 64, we can bring 64 in form of 2 power something. So we are going to be able to raise 64 as 2 to power 6. Now this one, even this one, it is 81. We know very well 81 comes from 3. So 81 is like 3 to power something. So 81 is 3 to power 4. So you're going to be able to bring this one in terms of 3. Here it is a clue showing that this one has to be also in 2. This one has to be in 3. Now if we go to part D. Part D is saying, part D is 1 over 27. Power is negative 2 over 3. Now the first thing here is to look at this one to see that the power is negative. Now we get the reciprocal of this, and the power will remain positive. So here we're going to have the reciprocal of this, it is 27. Now the power changes to positive, which is 2 over 3. After getting the reciprocal of this, the power changed to positive. Here, we know very well that 27 is 3 times 3 times 3. So it is 3 to power 3. This is 27. So again, power 2 over 3. So what I'm going to do there, it is these powers are going to multiply. So you're going to get 3, then 3 times 2 over 3. If you multiply this, these ones are going to die to remain with 3 power 2. And you can leave it here, or you can say that this one is equal to 9. Because 3 power 2 is the same as 3 times 3, which is 9. And the very last way of setting a question which is concerned of indices, but they won't show you that these are indices. What we have to do is to look at these ones and see, are these ones indices? And if they are indices, it means we have to get a way of handling them. Now, solve for x in this. You see, there is a 81 power something is equal to this. Now you go to your calculator and think of a number which is a factor here and a factor here. Now here we use prime numbers, and the prime number which is here and is having it is 81, which is equal to 30 times 30 times 30, which is the same as 30 to power 4. So instead of writing 81, you're going to change it to this. And even this one is 243, which is the same as 30 times 30 times 30 times 30 times 30, which is the same as 30 to power 5. So instead of writing 243, you're going to write 30 to power 5 and take back to their solution. So this is our solution. We have already started with the solution. So we are going to represent 81 as 3 power 4 and 243 as 3 power 5. So you're going to come out and say that 3 power 4 here. Again, power x is going to be equal to this one, it is 3 power 5, like that. Now we have simplified this one to this. Now here we know from the laws of indices that if we have a power inside and a power outside, we multiply the powers by maintaining our base. So it's a base, we maintain it at 3 and multiply the powers, which will give us 4x. After multiplying 4 times x, we get 4x. This one is going to be equal to 3 power 5. So 3 power 5. And if we have equal signs here and the bases are the same, it means even the powers are the same. So we don't deal with the bases. If the bases are the same, let us go to powers. So we say equating, because these are equal signs, we say equating powers. Here it means we are going to leave away these ones and equate these ones. So we say 4x is equal to 5. Here we can easily determine the value of x by dividing by 4. We divide by 4. Therefore, x is going to be equal to 5 over 4 as our answer to this question. Thanks a lot.